In this tutorial, I want to look at differentiation from first principles, and in particular to see where the rule actually comes from. Let's drop in a set of axes. I've got my x-axis and my y-axis, or f of x. Let's drop in a little function here. We've got a curve, and we'll start off with 2 points. Now between those 2 points, I want to actually drop in a straight line or chord. And the idea is I want to find the gradient of this line here. Now in order to do that, I will need the vertical distance over the horizontal distance. So the vertical over the horizontal. Now let's take this point here. What are the coordinates of this point? Well, in general, it's given by x, comma, y, or f of x. So we've got this point, and then we travel along this distance here along the x-axis and up to this point to get this second point. Now this distance here, let's assume this distance is quite small. It's a little bit of x. Now to represent that, we have delta x. So delta x literally means a little bit of x. So the coordinates of this point, that will be x plus the little bit of x. And the y-ordinate, well, here we've got f of x. But this time, x has been replaced by x plus delta x. Therefore, the y-ordinate will be f of x plus delta x. Okay, now I've got the 2 points. I need to calculate the length of this line here. Well, that will be the difference in the y-ordinates. In other words, this subtracts this. So let's write that down. We've got f of x plus delta x minus f of x. So now we can actually write down the gradient. So the gradient is given by the vertical distance, which is f of x plus delta x minus f of x over the horizontal, which is delta x. So that gives me the gradient of this chord here. Now what if I want to find the gradient at one particular point on this function? Well, that would be a tangent. So the tangent at this particular point here. Well, what I can do, I can move this point closer and closer and closer to this point. So let's say it was here. What that actually means is we have this distance being smaller and the delta x being smaller. And if I move closer still, delta x gets smaller, and closer still, delta x gets smaller. Now as delta x gets smaller and smaller and smaller as it approaches this point here, what's actually happening is that delta x is tending to 0. It's getting closer and closer and closer to 0. And what we say in that case is that, well, what we've actually got is f dash of x is equal to the limit as delta x tends to 0 of this gradient function here. So let me explain that a bit more. So this represents gradient f dash of x. You might also see dy by dx is equal to the limit as delta x tends to 0. In other words, this point is moving closer and closer and closer. We've got delta x becoming very, very, very small. And as it approaches this incredibly small number, we get this gradient of this tangent. And that is f of x plus delta x minus f of x all over delta x. So this is the rule that we apply for differentiation from first principles. And you'll find if you watch the playlist, I've thrown in a couple of examples for you to follow along with.